Good morning, everyone. I'm audible?
Yeah.
Yeah, good morning, sir.
Good
You're
morning,
audible, sir.
sir. Yes.
Good morning, you are audible.
Yes. Thank you, sir. हमारा आज का टॉपिक है सर कंक्रीट क्वालिटी मैनेजमेंट बाय इंजीनियर रतन कुमार झा. Engineer Jha, a accomplished civil engineer and industry leader with over 32 years of distinguished experience in the cement, construction materials, technical services, customer education, skill development, and market development domains. Recognized for developing and delivering large-scale training programs for engineers, contractors, masons, applicators, channel partners, architects, builders, and sales teams. Across North India, proven expertise in translating industry knowledge into practical skill development initiatives that enhance productivity, quality, safety, and customer satisfaction. A strong advocate of industry academia collaboration, workforce upskilling, sustainable construction practices, and competency development, adept at designing, training, curricula, conducting classroom and field demonstrations, mentoring professional, and creating technical leading content. Now I would request to Dr. Ratan Kumar Jha, please take over.
Thank you, Yuvrajji, and good morning to all of you. Already I have been introduced by Mr. Yuvrajji, and once again, just I'd like to brief about myself once again. My name is Ratan Kumar Jha, and I am basically a civil engineer. And I have recently resigned from the JK Cement Limited as a zonal head, North Division, in business development and customer technical services. Today's topic is much relevant. It is related to quality of concrete and its management. And I think all the participants might be associated with it either directly or indirectly in cement concrete or some projects also. So before wasting much of your times, just I am directly coming to the presentation part, right? Yeah, so screen is visible to all of you.
Yes, sir.
Yes.
Okay. So this is quality of concrete and its management, right? So first of all, the inheritance of cement and concrete. I think you might be aware that in year 1824, the Joseph Espadin, a renowned architect and builder from UK, has patented the Portland cement. And in India, the first cement company was the India Cement Company Limited, started from the Gujarat, Porbandar, and first delivered 1,000 metric ton of cement. Usage of RCC structure in civil engineering construction is less than around 150, 160 years now. Some of the oldest structure of RCC, that is reinforced concrete, are a 3-story structure at Baikula in Mumbai, is one of the oldest RCC structure in India. Others buildings are at Mount Road in Chennai, which were built in the 1903, and Har Ki Pauri in Haridwar, 1908. Some other prominent places are there, like in my hometown, that is Rajnagar, Darbhanga Raja has built many oldest RCC structure. Now it has become all the reuse structure now. But in any coming seminar, I will show some photographs of that particular monuments also. This slides reflect to the cement overview that nearly in India 700 million ton cement capacity are there, which Indian cement company altogether can manufacture annually. Average production is currently roughly 495 million ton per annum. Per capita cement consumption in India is at roughly 290 kg. Per capita cement consumption world average is nearly 470 to 520 kg approx. Per capita cement consumption in the China, that is 1,320 to 1,370 kg. From this slide, from this data, we can see where we are exactly. We are behind than the world average in respect to per capita cement consumption, and we are far behind than the China, which is our competitor and neighbors as well. I think you also know that any country's GDP growth is directly related to cement and steel consumption in their country. So we are lacking in this respect also. We all have to think over it. These are the different IS code for the different types of cement. There are 21, 22 types of cement in India. Some of are in general use, like OPC 33 grade now obsolete, OPC 43 grade, OPC 53 grade, OPC 53S for the sleeper grade, OPC 53S also the sleeper grade, which is used in the railway sleeper manufacturing, Portland slag cement. There are many other type of some special type of cement, and their respective IS code is there. When we talk about the concrete, as you all know, that concrete is the largest consumed man-made material on the earth, and it is largely consumed by the humankind after water. पानी के बाद सबसे ज्यादा कंज्यूम किए जाने वाला जो मटेरियल है, that is the concrete. And in concrete, these are the approx percentage consumption, that is 6% air. It is bound to happen. It is bound to there. 11 to 12% Portland cement, 41% gravel or crushed stone. Otherwise, we termed as a coarse aggregate as well. 26%
Safety in building ऊपर क्या है?
Sorry.
Safety in building. Construction
Sorry.
safety हूँ ले विजय.
Sorry.
100% air, 11% Portland cement, 41% gravel.
I'm not getting you. Okay. So 26% are fine aggregate, as I said, and 16% of water, roughly. These are the approximate constituent of any concrete. One second. After water, as I said, after water, concrete is the most widely used material on the earth. Nearly 30 to 35 billion metric ton per year concrete are being manufactured. And concrete outperforms most of the construction materials in terms of strength and durability, requiring very less maintenance. When we talk about the durability, it is very valid in very vague terms. So, important goals of concrete structure are, when we manufacture any structure or building, but as an engineer, what should be our aim? That first of all, the safety of the structure, then economy of that structure during constructions, durability of the structure, and of course, the sustainability of that particular structure. So, safety, economy, and sustainability are functions of durability. So, to get the safety, economy, and sustainability, we have to make our concrete, we have to make our structure much durable. Hence, achievement of durability is most critical in concrete-based construction, and it needs proper quality management process. We have to think over it. We have to take a standard rules and regulation at any project site where construction are going on. So, a basic definition of durability. Durability is the ability to last a long time without significant deterioration. It is directly related to the lifespan of the structure without any undue maintenance and repairing. So, a durable material helps the environment by conserving resources and reducing waste and the environmental impacts of repair and replacements. In another way, what is durability of concrete? It is the ability of concrete to resist the weathering action, like chemical attack, humidity, abrasion resistance or any other rainwater, etc., etc. So what are the durability requirement are? That is fulfillment of the requirements of structural safety and serviceability within the planned use and the foreseeable action without unforeseen expenditure on maintenance and repair, as I said in earlier slide. So it is durability means nothing else. It is a life span of any concrete structure without any undue maintenance and repair. So near about 50-60 years ago, construction engineers are not much concerned about the durability, because once we get the strength, of concrete during construction, we assume that the concrete structure will remain stable, remain safe, remain in service life for many years. So durability became an issue only when following problems were noted all over the world. Mainly in the UK and the USA, what happened during the winter season, during the heavy snowfall, when snow is overlap over the road and bridges, to ease the traffic at very early age period, they were putting salt over that particular ice to melt it very soon, and the traffic will resume. But due to this process, the icing by salt, several cracks in bridge decks were found. Kafi cracks usme aaye, this type of crack. So, and as we know, the major deterioration problems in the Middle East due to chloride-induced corrosion in particularly aggressive environment, mainly in Middle East. So severe cracking in a structure in many countries resulting from alkali-silica reaction. So these are the few regions where construction engineers, project engineers have started thinking about the durability as a main concern. They are started giving more emphasis or equal emphasis to durability parameters along with the strength parameter as well. So you can see the deterioration in bridges, which is various regions. So corrosion of reinforcement, the most severe mechanism of deterioration in concrete. And corrosions in rebar concrete happen due to many regions, not a single reason, they are due to many regions, but it is the main problem which the construction engineers are facing nowadays. So concrete, as we all know, that concrete is a durable material and its use dates back to more than 2000 years. I'm talking about the concrete, not RCC. The famous Pantheon in Rome, built in 126 AD, is an example of a concrete structure that has survived by nearly 2000 years. The Pantheon's dome is still standing and is the world's largest unreinforced concrete dam. The steel were not used in that particular dome structure. This is our Mumbai structure, that is Gateway of India, built in 1924. Still, it is very, very strong. The structure has 30-meter long RCC piles and domes of reinforced construction. The structure is hugging the Arabian Sea and is subjected to severe environmental conditions, but it is safe. So that is the traditional approach in tackling the durability issue in most of the national codes and the standards, including the European codes, is to specify certain dim to satisfy. इसको मैं थोड़ा आगे explain करूंगा. There are too many assumptions in this approach, and the term service life is often loosely used, since it is unclear as to which condition represent the end of service life. When we talk about the service life, it is very person to person. A good quality engineer, if he will see in the severe cracks in buildings, either in roof or cantilever portion or in column, they may treat as a unserviceable, and they immediately ask for the proper rectification or the repair. Another engineers wait for some years as well. So it is very, very subjective. Now this dim to satisfy approach, which is perceptive and easy to implement, is generally adequate for vast majority of simple structure. The same may not be true for major structure and durability critical structure. So on an average, the expected service life of a different type of structure are the monumental structure like temple, mosque or church is 500 to 1000 years. steel bridges, steel buildings or similar structure are 100 to 150 years. Concrete bridges or high-rise building or stone bridges are nearly 100 years. Residential houses nearly 60 to 80 years, and concrete pavements 30 to 35 years, and bituminous pavement are 8 to 10 years. It is a roughly estimated service life of different types of structure. So what are the factors which affect the durability directly or indirectly? First of all, the service environment in which they are withstand, or their structure, or their detailing, that is cover, shape and size of the members. Construction method, that is workmanship. It is very, very vital and important in respect to, if you talk about the Indian scenario. Type and quality of materials used, cement content and water cement ratio. Once again, very, very important technical parameters, which is mostly and majorly neglected. Repair and maintenance. So these 6 parameters which are directly affecting the durability aspect of concrete, and of course the concrete structure as well. So factors affecting the durability phenomena or parameters, we divide it into 2 parts. First of all, the concrete system itself, and the another is the aggressive environment itself. First, we talk about the concrete system. What are they? First of all, the material. If you talk about the concrete system, first of all, the material and process. What material we are using and what process of making of concrete, good quality concrete, we are adopting. So first of all, the materials, binder type, किस type के binder, किस type के cement हम use कर रहे हैं, binder content, that is quantity or percentage, aggregate in its type and quality, admixture, which type of admixture we are using, and the mixed design of concrete. These are the material selection. Another is process, mixing process, transporting in case of RMC, compaction, curing, temperature, and workmanship. This is the concrete system, which is totally in our control as an engineer. Another is aggressive environment of environment. In these, there are 2 types, that physical and chemical. Many of these parameters are not in our control. Of course, the physical, that is abrasion, erosion, cavitation, and freeze thaw. The abrasion, erosion, and cavitation is in our control. Freeze thaw totally depend on the climatic condition. Chemical, dissolution of salts, leaching, expansion, and alteration. So these few factors which are directly affects the durability aspect of concrete. If you talk about the deterioration mechanism, the most severe part of deterioration is reinforcement or pre-existing steel corrosion. I think all of you are aligned with my these assessments. I repeat once again, the most serious form of, or most general form of concrete degradation is due to reinforcement of corrosion of steel, and this corrosion of reinforcement happened due to many regions. So root cause of early sign of deterioration or distress of concrete structure in India are, I am talking about the Indian context only. So lack of professionalism and understanding of the nature and properties of concrete. First of all, since we are engineers, so we are talking and we should discussing our shortcomings. So inadequacy in current codes and standard. Still, there are many codes have already been revised, but still some codes are yet to be revised in concrete related matter. Design and detailing defects. I will show some photographs in coming slides. Poor workmanship or quality control at construction stages. In India, we have a huge manpower. We don't have the shortage of manpower, but we are lacking badly in the skilled workforce. Those who can execute the work properly and effectively. Those who understood the technicality of construction, those who know the technicality of concrete and steel structure. So we also have to work over it, and we have to get our workforce properly skilled. Poor maintenance or upkeep. Poor accountability and rampant corruption in the society. These are the few parameters in Indian context, the main cause of deterioration of concrete structure. So what are the lack of professionalism Many site engineers are unaware of the minimum number of cubes to be taken at site for acceptance of concrete. When I was in JK Cement and I used to visit many project sites, this is my personal experience. That's why I have written, and I am still believing that many site engineers are not aware how many cubes for each stage of concrete testing should be casted and tested. There is considerable ignorance regarding the benefits of use of blended cement. Still, even yesterday, I had a discussion among the very senior person about the usage of blended cement and quality parameters of blended cement. Still, some myths are there, not only in customer, those who don't know the technicality of cement and construction. I can say the majority of civil engineers, majority of project engineers are reluctant to use the blended cement. Generally, focus at site is progress and not quality. इसमें सारे इंजीनियर्स का भी दोष नहीं है. इफ यू वर्क इन एनी ऑर्गेनाइजेशन, वहां पर फोकस होता है कि वर्क टाइमली एक्सिक्यूट हो जाना, टाइम पर ये स्लैब और ये कॉलम्स ये कास्टिंग हो जाने चाहिए. There is no motivation or incentive to construction workers and supervisor for achieving the good quality of works. यहाँ थोड़ी सी लिमिटेशन भी हमारे इंजीनियर्स फर्टर्निटी की. There are lack of training and lack of adequate knowledge of site staff regarding methods to be adopted for achieving the desired quality of concrete at site. सर, यदि आप लोग कोई प्रोजेक्ट, यदि मैं आई डोंट नो, मतलब जो हमारे पार्टिसिपेंट्स यहाँ पर हैं सब लोग, मैं अर्ज करूंगा यदि आपके साइट पे इवन साइट इंजीनियर्स हैं, जब मैं जेके में था वी विश टू डू इट, यदि आपको कोई ट्रेनिंग सपोर्ट का सीमेंट कंक्रीट पर आपके टेक्निकल स्टाफ सुपरवाइजर वगैरह को यदि एक 1 डे का ट्रेनिंग कराना है, 2 दिन का ट्रेनिंग कराना है, टू नो द फर्स्ट ऑफ ऑल KYP, नो योर प्रोडक्ट्स. आप अपने पहले प्रोडक्ट को जानिए जो आप यूज कर रहे हैं, देन उसकी क्वालिटी को जानिए, नेग्लिजेंस जानिए, डू डोंट जानिए. तो सर, मैं यदि यहाँ पर कोई ऐसे जेंटलमैन हैं हमारे, ऐसे कोई इसमें हमारे ऑडियंस में हैं, पार्टिसिपेंट्स हैं, यदि आपके साइट पे यदि कोई प्रॉपर ट्रेनिंग की हो, ट्रेनिंग में भी फॉर 1 डे, ट्रेनिंग में फॉर 5-6 आवर, ट्रेनिंग में फॉर 2 डे 3 डेज और इवन 1 वीक, जैसा जितना टाइम मिलेगा उतने डेप्थ में जाके ट्रेनिंग होगा. और वी एट इवन CIDC वी आर रेडी टू रेंडर ऑल द सपोर्ट्स to your staff member, to your project members. So we have to discuss about this if you require such type of services from us. So many of the engineers responsible for quality control at site are not aware that there is a separate code production and supply of ready mix. Sir, यदि साइट पे जो कंक्रीट बनाते हैं और जो RMC के हैं, there are 2 different codes. When we pour the concrete at site, that concrete code we are following that IS 456. Whereas for RMC, we are following IS 4926. If you ask many engineers, they are not aware about the same. Inadequacy in current code. I am talking about the cement code only. The IS 1489 part 1, that is fly ash based cement, is still, we are getting regularly the 28 days cement strength, compressive strength of PPS cement is nearly 53 to 58 MPa at the age of 28 days. Still, as per the code, requirement is only 33 MPa. Why it is not being revised? ये रिवाइज होने चाहिए. यदि हमें 50, 55, 56, 58 हमें MPa आ रहा है, like 43 grade, and that is the reason many site engineers, many customers are not using, or rather they are reluctant to use blended cement, fly ash based cement, because they are thinking that this is an inferior cement. But the fact is just reverse. If you use blended cement, either PPC, that Portland pozzolana cement, PSC, that is Portland slag cement, it has much technical advantage over the ordinary Portland cement, whether it is 43 grade or 53 grade OPC cement. These codes follow traditional prescriptive and simplified approach. Okay, just for the other, the current philosophy is more towards performance-based approach for reliability and design service life. See, design defect. When here we are responsible. You can see some of the structure which were collapsed after either just after the completion of project or during construction itself. Some Mount bridges in Goa 1986, building collapses Chennai 2014, Danga flyover Kolkata 2014. One that bridge in near Silchar, Assam. This is the Ganga River in Patna. The problem of dropping cantilever bridges are well known, and several bridges in India are in bad shape, practically unserviceable. We are talking about the good detailing. You see the photographs of that is good detailing in the left hand side and the poor type of bad detailing of reinforcement. And all these photographs are taken from the actual site. This is not a computer generated Photoshop. It is the actual site. So you can see the differences in these two photographs. Okay. Poor workmanship. Poor workmanship at site is a result of several factors. Major factors are lack of accountability of individual engineers. मैं यहाँ हम अपने इंजीनियर फ्रेटर्निटी को ही ब्लेम करना चाहूंगा. It is our duty. So we should have some trained applicators, those who execute the work. यदि आपके अंडर में आपके साइट पे ट्रेंड सफिशिएंट मतलब वेल स्किल्ड वर्कफोर्स नहीं है, it is your duty to either you skilled them or you get it skilled from the other agency like us, that is कंस्ट्रक्शन इंडस्ट्री डेवलपमेंट काउंसिल. ये आपको बस करना पड़ेगा. अदरवाइज आप कितना अच्छा भी डिजाइन कर लें, कितना अच्छा भी आप मतलब ड्राइंग बना लें, द वर्क आपका उतना अच्छा नहीं होगा जिसके लिए आप उस पर काम कर रहे हैं. लैक ऑफ अकाउंटेबिलिटी ऑफ इंडिविजुअल इंजीनियर्स, lack of adequate numbers of skilled laborers, qualified technical staff, and proper tools and equipment at site. Lack of effective supervision. It is also very, very important part. So the effects of poor construction methods are, ये तो वर्कमैनशिप और कुछ डिटेलिंग डिजाइन डिटेलिंग और इसकी बात हुई. द नेग्लिजेंस कहाँ कहाँ होता है? लीकेज ऑफ स्लरी थ्रू शटरिंग. आई हैव सीन, आई एम द विटनेस ऑफ दिस. मैंने ये देखा है. कंक्रीट पॉरिंग हो रही है, स्लरी के लीकेज आ रहे हैं, नो वन इज केयरिंग. इनकरेक्ट प्लेसमेंट ऑफ स्टील, जस्ट आई हैव शोन. inadequate cover to reinforcement. कवर ज्यादा मतलब sufficient cover as per code नहीं दिए गए, that I will show in coming slide. Incorrectly made construction joints, grout leakage in pre-stressing ducts, poor compaction, segregation, poor curing. So these are the negligence. Even we as an engineer know the after effect. यदि हम इसको neglect करेंगे क्या दिक्कत आएगी ये हम जानते हैं, but somehow we are neglecting it. That should not be done. Poor maintenance, of course. So, result of poor maintenance during service life of any structure, you can see some patches and some stains which directly or indirectly affect the durability and span or life of any structure. Poor accountability and rampant corruption in the society. There are massive amount of bribery and corruption in the construction sector in India, particularly in government sector. I'm not directly blaming, but we all know how work is done and how commission are distributed and how commission are being asked, even in private sector as well. Not every places, at some places. Coupled with the corruption, there are two passive attitudes that we find prevent in our society. One is the motion of chalta hai, and the other is concept of जुगाड़. जब हम बात करते हैं ना, ये सारी चीजें जो है मैं अपने जो सर्विस लाइफ मेरा रहा है उसके आधार पर मैंने ये बनाया है और मैं आपसे डिस्कस कर रहा हूँ. दैट चलता है एटीट्यूड. When we are compromising with our goal, then only we use this word that is चलता है. I have heard नहीं, अरे सर ये सब हो जाता है, सब चलता है सर, सब में कोई ऐसी दिक्कत नहीं. When we talk about the quality of water, pH value of used water in customer site, अरे सर ये चलता है सर, यहाँ कहाँ ऐसे हो पाता. Of course, it is affecting your quality of construction, quality of concrete, and ultimately the life of your structure. And another is the jugaad technology, compromising the quality parameters. So we have to think over it very seriously, and we as an engineer, we are a part of nation building. So we have to start a very positive campaign that it नहीं चलता है, ये नहीं चलता हमारे यहाँ, हमें तो ऐसे करना होगा. And still there is a new rainbow of hope, at least from the new generation. So a live example of the jugaad technology, picture itself tell the story. ये क्या कहानी क्या है? You can see मिट्टी खुदाई हो रही है, इंस्टेड की थोड़ा डीप है, जाने के बदले दो बंदों ने पकड़ा, उसको उल्टा लटका दिया और वहां से मिट्टी निकाल हो रहा। तो वी नीड टू चेंज। स्टिल वी हैव द रे ऑफ होप। सिलेक्शन ऑफ हमें कर, ये सब हुआ, क्या क्या हो रहा है, व्हाट वी शुड डू, और क्या हमें बेहतर करना है। फर्स्ट ऑफ ऑल सिलेक्शन ऑफ मटेरियल। जब सिलेक्शन ऑफ कंक्रीट कंस्ट्रक्शन की बात करेंगे, फर्स्ट ऑफ ऑल द सीमेंट। सीमेंट should be used, should be purchased with the brand reputation from the reputed manufacturers and the totally on the based on quality parameters. Sand, river or crushed sand, the silt should be must be less than 5%. Aggregate, cubical in shape and innocuous. Water pH value should be between 6 to 8. Admixture from reputed manufacturer, and before using the admixture, we must check the compatibility with the binder, that is the cement. Cement, the sales cement is a hydraulic binder and it should be chosen on actual quality parameters, not on perception or attractive advertisement. PPC, PSC मैंने ऑलरेडी बता दिया है, ये मिथ को हमें तोड़ना पड़ेगा। और when we talk about the durability aspect, PPC or PSC, that is Portland Pozzolano cement or Portland slag cement, having much advantage than the ordinary Portland cement. That I can assure you, as I have worked many years in cement company. So why blend cement? Based on performance and environmental benefits. What are they? If you compare ordinary Portland cement versus the PPC cement, cement plus water in both the cases. Primary hydration occurs in both the cases. After primary hydration, what happens? CSH gel formed and calcium hydroxide liberated. In PPC also calcium silicate hydride gel and calcium hydroxide is liberated. Up to here, the similar chemical reaction happen in OPC and PPC. After that, in OPC, what happened? Degradation of concrete started. Because why? Because that is liberated calcium hydroxide is within the cement concrete. It is not reused. But in case of PPC, first of all, the OPC, that calcium hydroxide react with the carbonic acid from the environment. In addition, and humidity plus carbon dioxide, it converted into the calcium carbonate, which is insoluble. Once again, in combination with the carbonic acid, that calcium bicarbonate, it is soluble in water, and leaching of concrete is started in terms of efflorescences, and that leaching of concrete makes your concrete more porous, more vulnerable, and this is the main reason. This is one of the main reason for your reinforcement corrosion at early ages. Very early ages, I can say within 2 or 3 after 2 or 3 years of construction of your bridge or any concrete construction. Whereas in Portland Pozzolano cement or Portland slag cement, what happened? This CSHL calcium hydroxide, since you have added fly ash, and in fly ash a sufficient amount of silica is present. That silica reacts with the calcium hydroxide in the presence of moisture and converted into the additional CSH gel. That calcium silicate hydride gel makes your concrete more denser, more thicker, and more denser concrete have lesser permeability, and the leaching of concrete is almost nullified and makes your concrete more durable, having more service life. All the black particles, black dots, black particles are CSH gel. In case of Portland Pozzolano cement, these particular dense particles are less in quantity, less in volume, hence your concrete will become more denser, and permeability of concrete is lesser, and resulting which the strength and durability increase significantly. Usage of high quality of fly ash and the high reactive silica, that's fly ash. Type of SEM images of normal fly ash. How fly ash increase the property of concrete? First of all, the dispersion of cement particle, availability of larger surface area for hydration, because fineness of fly ash is much larger, and we have a larger surface area for the hydration. Reduction in amount of trapped water between the cement particle, because it is more denser. Particle packing effect, reduction in voids, as I have seen. This, if in between these two particles more CSH gel form, so voids will reduce and your concrete will become denser. Reduce water requirement to achieve a given consistency. Ball bearing effect, that I will show in Spherical shape reduces interparticle friction, and due to this interparticle friction, at early ages, some stress will develop and concrete structure cracks. But in case of PPC, that due to ball bearing effect, the interparticle friction is significantly reduced, and the stress is ultimately reduced, and there is minimal chance of cracks at an early ages. See, this is the ball bearing effect. In every type of construction, we can use the blended cement, PPC. Effect of water cement ratio on durability. Permeability is the contributor factor for volume change, and higher water cement ratio is a fundamental cause of higher permeability. As I have just said, if you increase the water content into concrete, it is a thumb rule. I have heard from some very learned concrete engineer. If you increase water content by 5% into concrete, the strength of concrete will reduce by the 5%. Sorry, 15%. Not only strength will reduce due to higher permeability, durability, or you can say the life of your structure will drastically reduce. Use of higher water cement ratio, permeability, then the volume changes, cracks develop, and disintegration of concrete. Failure of concrete is a cyclic process in concrete. This is the use of higher water cement ratio, resulting which what will happen? The permeability will increase. Permeability increase, the volume changes. Volume changes, that cracks will appear or disintegration. And if your concrete is disintegrate, failure of concrete is bound to happen. For a durable concrete structure, use of lowest possible water cement ratio is the fundamental requirement to produce dense and impermeable concrete. Nowadays, with a high quality of polymer based plasticizer and admixture, even you can make concrete low as even 0.3 water cement ratio, 0.29 water cement ratio also. Process. This is the concrete quality management. I am skipping few slides. So as far as the workmanship is concerned, these all are related to the workmanship. The first of all, the patching of concrete should be very genuine and fair. Mixing of concrete should be theoretically done. Transportation within the specified limit. यदि आरएमसी से कंक्रीट आ रहा है तो कितने टाइम में वहां से जाना है और ट्रांजिट मिक्सचर को कितने बजे तक पहुंचना और कितने बजे तक कंक्रीट कास्ट हो जाएगा, दैट शुड बी प्लान्ड अर्लियर. Placing of concrete very important. Compaction equally important. Finishing having some significance. Protection of concrete during if you cast concrete in a hot and humid condition, mainly in hot condition like when in northern India when temperature goes around 50 degrees C. After pouring your concrete to early shrinkage cracks, you have to protect your early or green concrete through a polythene or anything. And last but not the least, that is curing, which is partly, it is most of the site, even the project side or individual housing, it is neglected. Compaction of concrete, it is very important. Even 1% void reduces your concrete by 5%. Curing, I have already explained. So as per IS 456, if you use OPC based 7 days, blended cement in normal condition 10 days. In blended cement, PPC or PSC, you have to do the curing for little bit more days because the chemical reaction is happening even not only 10 days, even 28 days, 3 months, 6 months, 180 days. So you have to cure the concrete in longer period of time if you use the blended cement. Chemical environment. So types of chemical attack, that sulfate attack, alkali aggregate reaction, chloride ion attack corrosion, carbonation, acid attack, and effect on concrete in seawater. These are the chemical action which is directly happen to concrete. So sulfate attack, I'm not going to explain each and everything, each and every slide. Some slide I'm skipping. So due to alkali, and another is the alkali aggregate reaction, you can see. So here what we can do, remedial measures, use non-reactive aggregate from alternate sources, use of low alkali cement, reduce cement content in concrete, use of pozzolana slag or silica fume, control on service condition, limiting degree of saturation of concrete. Fluorides in concrete as per IS 456, chloride concrete increase the risk of corrosion of steel, that is electrochemical reaction. Higher chloride content on exposure to warm moist condition increase the risk of corrosion. Even in cement, we have to maintain the chloride content in cement is less than 0.1%. But chloride content is not increasing in concrete due to not only cement, some other sources like even water and your soil and other aggregates also. So we have to take care of it also. To minimize the chance of corrosion, the levels of chloride in concrete should be limited. Total amount of chloride as per in concrete at the time of placing is provided by IS 456 2000. Corrosion is an electrochemical process, the basic mechanism. So chain reaction, I'm not going to explain, just I will show some images also. You see, due to corrosion, what we have to face. Crack form due to bursting pressure on account of rusting of reinforcement. You can see the cracks. Look, methods of controlling the corrosion. हम corrosion को कैसे control कर सकते हैं? ये तो हुआ, ये होता है. How we can control as an engineer? Limit the chlorides in water, cement, and plasticizer to acceptable level. Number one. First of all, the cement, then water, and the plasticizer what we are using. Provide proper cover as per IS norms that I will show in coming slide. Cover blocks also need to be of good quality. कई बार cover blocks ही break हो जाते हैं. Concrete should be properly compacted, very very important, and it is related to the workmanship. Make dense, impermeable, waterproof structure. Add protective coating wherever suitable. Ensure proper and timely maintenance of structure. You can see images. Cover to reinforcement, I am talking about in mild condition, minimum 20 mm, moderate 30 mm, and it is given in code IS 456 2000. Severe condition 45 mm, very severe 50 mm, and extreme condition that is 75 mm. We all should know about this. So this is a happy family, a photograph set. In this photograph, a strong message for the quality concrete engineers. That means in our family, each and every member has some role. सबकी अपनी अपनी value है, value creation है. So in concrete, आप ये फोटो देखें, बूढ़े बाबा है, अम्मा है, that is a fly ash. Each and every member we have denoted some water, fine aggregate, coarse aggregate. That means in this, hello, yeah. So each and every members contribute in family. So in case of concrete, each and every constituent have some role in making a good quality of concrete. So what are the concluding remarks with these slides? So strength and durability are two important properties of concrete. We, as an engineer, when we talk about the concrete, we are giving more emphasis on the strength parameter only. But nowadays, when making a concrete, making a structure itself is very, very costly affair, tricky affair. So we as an engineer should think about the durability aspect also. And nowadays in urban sector, high-rise buildings are in use at massive level. So durability aspect, that means the lifespan of that particular structure having much important. So to make our concrete structure much durable, having larger span of service life, what we should do? First of all, selection of ingredient. जो selection हम material use करेंगे, that should be proper as per the based on the quality parameters. Right type of materials and right concrete for appropriate end application. कहाँ पर क्या use करना है? यदि आपको कोई सीवर लाइन में काम करना है, सीवर जहाँ पर SO2 गैस वगैरह का ज्यादा रोल होगा, वहां पर हमें सल्फेट रेसिस्टिंग सीमेंट यूज करना है. वहां पर हमारा ऑर्डिनरी पोर्टलैंड सीमेंट विल नॉट गिव रिजल्ट व्हिच वी एक्सपेक्ट. Next, design, batching, mixing, transportation, placing, compaction, finishing, and protection and curing. These all comes under the workmanship. तो workmanship पर हमें बहुत ही ज्यादा रोल मतलब फोकस करना है. Reinforcement, detailing, and adequate cover, जो अभी हमने बात की है. Good quality formwork, that is shuttering, etc. Maintenance and upkeep. Proper maintenance, timely maintenance. It is very important. So, in final sentence, what we can say, concrete is a dependable construction material. Why it is dependable? Because we are manufacturing, we are casting the concrete. It is not a natural material. We are making concrete by the use of cement, sand, coarse aggregate, water, by chemical admixture. So it is depend on our construction practices. So concrete is a dependable construction material and it should not be abused to the limits. Instead, it should be used with understanding, love and care, and needs proper quality management system. If you talk about the proper quality management system, we have to think over all the 4-5 parameters which I have given: selection of ingredient, right type of materials, mix designing, batching, that is the workmanship, reinforcement detailing, good quality formwork, and maintenance. So if we adopt all these things, if we able to make concrete with the more precise and concern, there is no doubt we'll have a very, very good construction. So this is all about the concrete quality and its management. So any questions out of it? Hello.
Any question?
No, sir.
No question.
Sir, hello, can you hear me?
Just a minute. Just a minute. Yes. Tell me.
Hi, sir. My name is Ravindra Patil. I'm working for US Corps of Engineers. So,
Just
early,
please speak loudly.
for the early strength concrete, if you use the fly ash, so because early strength concrete we have the while using the fly ash, can we achieve the early strength?
Exactly. What is your name, please?
Ravindra Patil.
Yeah, Mr. Patil, if you want to have the early age strength, here the PPC cement has some limitation. Okay, because if you use the PPC cement, the heat of hydration is bit less. So at the age of 7 days, compressive strength is bit lesser than the OPC cement. But at the latter age strength, that is 28 days and more, the compressive strength of PPC is going to increase, and having at 28 days, it is equal to the OPC cement, and at the latter age, let's say 90 days or 6 months, will have better compressive strength than the OPC if you use the PPC cement. So if your that is your main aim to have the compressive strength at higher at the lesser age, that is within 7 days, then you have to think to use PPC cement. You must have to use OPC, even if you have to use the rapid hardening cement.
Okay.
Any other
Sir,
question?
one more thing, sir. Regarding there is any thumb rule to based on the durability we can decide the concrete water cement ratio?
Just repeat your question, please.
There is any thumb rule to decide water cement ratio based on the durability?
No. You see, durability depends on many factors. So while designing the concrete, first of all, you need to have your target mean strength. See, if you are constructing a 15-story building, okay, and for you have to cast the foundation. So if you are going to use the M50 concrete, or M45 concrete, so you should have the target mean strength. So for target mean strength, once you have, and based on the IS 10269, the IS code for the mixed design of concrete, you have to choose the water cement ratio. It is a part of mixed design of concrete. There is no thumb rule. for the higher grade of concrete, you have to use the water cement ratio based on your mix design. Of course, as per the nominal mix, say M20, M25, you have to minimize the water content in your concrete to have the lesser permeability. And for that, if you decrease the water content in your cement concrete, so you have to you will be compromised with the workability. To get the workable concrete at lesser water cement ratio, in that particular case, you have to use the admixture, which will make your concrete workable at lesser water cement ratio. You got my point?
Yes, sir. Thank
Yeah.
you very much.
Thank you. And one more request, I think in my previous seminar also, I have requested the participants. So I think I have mentioned my mail ID. If not, if you have not written yet, my mail ID is ratan.jha, RATAN .JHA 66 @gmail.com. I repeat, ratan.jha, RATAN.JHA 66 @gmail.com. And my mobile number is 9582250226. Once again, I repeat, 9582250226. I request all the participants, please give your feedback. What you have learned from this particular topic? What is your expectation? What information lacking in this particular information sharing? So when I will come in coming seminar, I will come with that particular lacked information which I am not able to share with you currently. And what topics you want in your further webinar? ये यदि आप लोग शेयर करेंगे तो हमें और योगराज जी को सिलेक्शन ऑफ टॉपिक चूज करने में काफी हेल्प मिलेगी, राइट? सो
हाँ डॉक्टर झा
जी,
गौरीशंकर दुबे फ्रॉम दिस साइड, आपने
गौरीशंकर
75 स्लाइड में बहुत अच्छा आपने कवर किया है।
जी,
तो हमारा दो प्रॉब्लम है जिसका सॉल्यूशन आपसे मैं चाह रहा हूँ।
जी सर,
पहला
एक सेकंड,
है कि
एक सेकंड जरा रुकिए, मैं जरा अपना स्क्रीन पहले बताइए जरा।
हाँ, तो उसमें मेरा
जरा
जो
सर कैमरा,
प्रॉब्लम है,
इफ पॉसिबल गौरी शंकर जी जरा वो तो कैमरा ऑन कर लीजिए ताकि रूबरू तो नहीं हो रहे, कम से कम।
कल आपसे मुलाकात हुई थी CIDC में।
अच्छा 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 अच्छा, यस यस यस, हाँ हाँ जी,
तो
बताइए
मेरा जो प्रॉब्लम वी आर फेसिंग,
जी।
that is the quality of water used in ready-mix concrete batching plant.
Yes.
That is a concern. Mostly I have found they are not so serious about the quality of water.
जी
Second is underground subsoil water
जी
and the nature of it and the effect of the foundation concrete about their sustainability and durability.
जी
This topic is haunting us, being a project man,
या
and I would be grateful if you, a veteran like Ratanja, gives us some guidelines.
नाइस सर,
Thank you, sir.
ये मैं जरूर करूँ, और शायद आप जब CIDC आते हैं तो मैं वहां बैठता हूँ, विल हैव अ डिस्कशन इन लेंथ इस पर्टिकुलर टॉपिक पर भी, ठीक है? और मैं आगे के स्लाइड पे से बात करूंगा। ऑफ कोर्स जो नॉट ओनली क्वांटिटी ऑफ वाटर प्लेज ए वाइटल रोल इन कंक्रीट कंस्ट्रक्शन। सो हमें इस पर सोचना पड़ेगा और सोचना चाहिए भी, ठीक है? तो जैसे गौरीशंकर जी ने अपना फीडबैक दिया, आई वंस अगेन रिक्वेस्ट ऑल द पार्टिसिपेंट्स कि ये फीडबैक अपने दीजिए, कुछ क्वेरीज करें ताकि ये मीनिंगफुल और ये टेक्निकल इंटरेक्शन हो। इट इज नॉट ए जस्ट नॉलेज गिविंग प्लेटफॉर्म, इंस्टेड इट इज ए नॉलेज शेयरिंग प्लेटफॉर्म। इस तरह से संडे में भी, वीकेंड्स पर हम आप सब लोग टाइम दे रहे हैं, तो इट शुड बी ए नॉलेज शेयरिंग वेबिनार। हम एक दूसरे से शेयर करें, दैट विल बी मच बेटर। तो योगराज जी,
सर,
योगराज जी
सर,
आगे के जब काटले जब मेरा सेशन हो ना, जब आप लिंक भेजे ना, उसमें
हाँ।
एक नोट बना के भेजें कि सर ये टॉपिक्स हैं, इफ यू आप अपने क्वेश्चन के साथ जरूर आइए। यदि मैं हो सकता है मैं अभी आंसर नहीं दे पाऊं, तो आई एश्योर यू एंड आई एश्योर ऑल द पार्टिसिपेंट, आई विल अरेंज द आंसर। मैं अपने कंस्ट्रक्शन फ्रेटर्निटी से, सिविल इंजीनियरिंग फ्रेटर्निटी से, जो हमसे काफी सीनियर है, मैं वो आंसर अरेंज करूंगा। इट इज माई ड्यूटी। ठीक है? तो ये
ठीक है
क्योंकि
सर।
जब कन्वर्सेशन नहीं होगा ना, तो मजा
जी
नहीं आता।
जी बिल्कुल।
और यदि हम ये टॉपिक संडे को रख रहे हैं, हम लोग बात कर रहे हैं, तो इट शुड हैव द म्यूचुअल बेनिफिट ऑफ अंडरस्टैंडिंग एट लीस्ट। ठीक है? तो थैंक्स अ लॉट एंड हैव ए नाइस weekends to all the participants. Thank you once again. Thank you, Yogaraj ji.
Thank you, sir.
Thank you. Thank you.
Thank you,
Thank you.
everyone.
Good morning, sir.
Sorry.
Good morning, sir. Myself Subhabrata Rai.
Thank you very
Actually,
much.
sir, I have one question.
Shubham?
Subhabrata Rai. Sir, I have one question.
Yes. Tell me, Mr. Shubham.
Sir, actually, just I want to know whether this flyers, filling of flyers in a foundation is allowable or not.
Fly as? Just simply
Filling-
fly as.
Yes, sir. Suppose in a project, in a
Yeah.
power project,
Yeah.
the availability of good earth is very less, and
Yeah.
there is a production of fly ash inside the plant.
Yeah.
And can we use that fly ash to fill up the foundation? Is it
Yeah.
acceptable technically, or what is the it's
Mr. Shubham,
do's and don'ts?
I think the fly ash are being used in many ways. Some of the at some places it is a replacement of cement. At some places as a filler in even in concrete, that is replaced by some part of sand. And as many places as a filler material, simply even in highway, bridges, etc. So I think just as a filler material, just like earth or anything, I don't see any harm in it, provided it will be compacted properly. Because I have seen, and one of my friend is project in charge of that is Delhi Baroda Expressway highway near about the Badarpur thermal plant. I have seen the fly ash are being dumped and filled in the foundation beneath the bridge. So I don't see any harm in it, and I think no IS code are preventing to use it. So I think it will be used.
Thank you, sir.
Okay. Any other question? So that's fine. I think आप लोगों ने question पूछा, and that should be the spirit. यदि इस तरह question sorry. चलिए, तो योगराज जी ठीक है, यदि कोई आगे क्वेश्चंस आते हैं तो मुझे मेल में भी लिख सकते हैं, आई विल रिप्लाई टू देम. ओके, थैंक्स जेंटलमैन, थैंक यू
Thank you,
Thank you,
everyone.
sir. Thanks a lot.
Thank you, sir, for nice presentation.
Thank you.
Thank you, sir.